Hi, my name is Vincent, and today I want to look at some multiple choice questions, no calculator, from the AP Calculus AB version of the test. So we have, what is the x-coordinate of the point of inflection of the graph of y equals, and we have a function. Now here's the thing, when you study for this test, you have to have an automatic response to phrases like point of inflection. That means find out where y double prime equals 0. So the first thing we need to find is the first derivative. We use power rule. And the derivative is going to give us x squared plus 10x plus 0. So we're just using power rule for derivatives here. But point of inflection means find the second derivative. So if you do another derivative, you're going to get 2x plus 10. And we set this expression equal to 0. And this is going to give us x equals negative 5. Now, we can stop here because non-existent is not an answer choice, but get in the habit of when they ask for a point of inflection, you have to look for a sign change in your second derivative. So if you plug in something like negative 6, 2 times negative 6 plus 10 would be negative 2, so we could label this interval negative. If you plug in something to the right of negative 5 like 0, you'll wind up with positive 10. So since there is a sign change for y double prime, x equals negative 5 is definitely the site of a point of inflection. For the next question, we have a piecewise function, and they want us to find the value of this definite integral. So this is telling us to look for the signed area under the curve. Now, the reason why I say signed area is because area under the x-axis has to be treated as negative, and area above has to be treated positive. And these are two trapezoids, so they gave us easy shapes on purpose. So the area of the first one, where the base 1 is equal to 1, base 2 is equal to 3 here, if we just count across, and the height is equal to 2, we're going to use 1/2 times height, which in this case is 2, base 1 plus base 2. So if we find the value here, this is going to be 4. So the first trapezoid has an area of 4. To find the second trapezoid here, because we're going from negative 1 to 4, this is telling us where to start and stop. This base is going to be 2, this base is 1, and the height is equal to 1. So we're going to have 1/2 times 1 times 1 plus 2, and half of 3 is equal to 1.5. So to simplify this question here, if we want to find the value of this definite integral, we're going to have positive 4 plus negative 1.5. And this works out to 2.5. So in this case, the choice is B. Please do not fall victim to the trap of adding those two together. Choice D is very distracting, and that is the one people will choose if they miss the concept here. For this question, we're just going to use Fundamental Theorem Calculus Part 1. So the first thing we should do, though, don't do anything crazy like a U-sub or natural log integral. This one is already starting to distract us. You're just going to call this x to the negative 2 dx, and you're going to use the power rule. So this is going to be x to the negative 2 plus 1 divided by negative 1, which just makes this negative, and we're evaluating this from 2 to 1. Now, just a general tip with negatives, put them outside of parentheses, then plug in the numbers and subtract, because you'll have less negatives to keep track of, and you're more likely to do this accurately. 2 to the negative 1 is 1/2. 1 to any power is 1. So this is negative 1/2, which is equal to 1/2. And that's this choice here. For the next question, you have to memorize theorems. Okay, so anytime I hear the phrase a function is continuous on a closed interval and differentiable on an open interval, I am automatically thinking of Rolle's theorem and mean value theorem here. Okay, so those two just pop into my head, but we'll see how this problem takes shape. But remember, if a function is continuous and differentiable on a closed and open interval respectively, mean value theorem has to follow. And you should recognize that choice A is mean value theorem. The instantaneous rate of change equal to the average rate of change for some value C between A and B. So this one is always true. Now, part B is saying f prime of C has to equal 0 for some value C between A and B. The one condition that we need extra for Rolle's theorem is that the function is equal at its endpoints. But notice in the givens, they didn't say anywhere that f of A was equal to f of B. So Rolle's theorem for choice B does not necessarily apply here because it's missing this component here. Now, just before we move on, we should show that the other ones have to be true as well. Because we have a continuous function on the closed interval, the closed interval method will apply. And that means the function will have an absolute minimum and absolute maximum. So choices C and D are out. And also, if I draw a function in one continuous shot between 2 points, it will have area under its curve. Okay, so the fact that there's no vertical asymptote is not going to be a problem for us if we did want to find the area. So that's why choice E will always have to be true. But B is false because we didn't necessarily say that this is true. For question 5, the most distracting choice is A. Please do not confuse this with FTC part 2. A lot of people, when they read this, think of this theorem here, that if I take the derivative of the area function from 0 to x of sine t dt, that I get sine x. But there is no derivative. See how this component is not in front? So this means use FTC part 1. And if we apply FTC part 1, we're going to have negative cosine t as our antiderivative. And we're evaluating this from 0 to x. So we leave the negative outside and we'll have cosine, and we replace t with x minus cosine of 0. This gives us negative cosine x minus 1. And if we distribute the negative and write the constant first, we'll have positive 1 and negative cosine x, which is choice E. Okay, for this question here, we have an equation, and they're telling us when x equals 2, dy dx equals. Now, for this question, we have the option of doing implicit differentiation, but if you can solve for y and the function is easy, then always do that. So for this one here, we have x squared plus xy equals 10. So we could rearrange this. We'll have x times y equals negative x squared plus 10 after we subtract x squared from both sides. And now we divide both sides by x. And we'll have y equals negative x plus 10 times x to the negative first power. So then dy dx, if we use power rule, we're going to have negative 1. And then we'll have minus 10 times x to the negative 2. So then for this part here, we're just going to plug in 2. So the derivative at x equals 2 is equal to negative 1 minus 10 times 2 to the negative 2. And this is going to give us negative 1 minus 10 over 2 squared is 4. And this simplifies to, we'll have negative 1 minus 5 over 2 if we reduce this. And then we simplify to negative 2 over 2 minus 5 over 2, which is negative 7 over 2, choice A. For the next question here, once again, don't fall victim to the trap of trying a U-substitution. Always try to do algebra before you try a U-sub. And if we divide everything by x, x squared over x is equal to x. And then we have minus, and we can leave this as 1 over x. Because now these two terms on their own are easy to take the antiderivative of. So we use power rule, and we'll have x squared over 2, which is 1/2 x squared. And then minus the antiderivative of 1 over x is natural log absolute value x. And we're evaluating this from 1 to e. So for the next part here, if we plug in, I recommend putting 2 sets of parentheses. We'll have 1/2 e squared minus natural log, and absolute value of e is just e because e is positive, minus, and then we plug in 1. So I'll have half of 1 squared minus natural log of 1. And natural log of 1 is equal to 0, so that goes away. And this simplifies to 1/2 e squared minus 1 minus 1/2. Which if we match this to an answer choice, the first term could be called e squared over 2. And then if we call this 2 over 2, minus 2 over 2 minus 1 over 2 is minus 3 over 2, which matches choice E. For the next part here, this question is a bit tricky, so really pay attention to this one. With any type of problem where they give you an if-then, you have to always make sure that you assume the if part to be true. That's the key. If you get stuck, you have to ask yourself, why did they tell us the information that they told us. So we have h of x equals f times g, and then they give us another definition for h prime. So for this example here, you want to think, because this is a product of functions, we could also express h prime using the product rule, that it's f prime g plus f of x times g prime of x. But then what we should notice here is that now we have two expressions for h prime of x. So we could set these two equal to each other. That is, we could say f prime g plus f g prime has to equal f of x g prime of x. And then something that should jump out is that we have matching terms on both sides. So we could subtract f g prime from both sides, and then we get here. And if you get stuck at this part of a problem, this is where you go back and say, why did they tell me the rest of the information? Like, how can we make use of Roman numeral 1 and 2? Well, what they're telling us in Roman numeral 1 is that this term is always positive. So what this implies, if this term is always positive, one of them have to equal 0. So if g of x always has to be positive, then f prime will always have to be 0. And if our derivative is always 0, then that means our original function has to be constant, because the derivative of a constant is 0. So now by condition 2, f of 0 is equal to 1. But if we plug into our function, f of 0 has to equal the constant, which tells us that f of x has to equal 1, since k has to equal 1 based on these two equations here. So that answers the question. F of x has to equal 1. For the next part here, we have the flow of oil, and this is a key part, in barrels per hour through a pipeline is given by the graph above. And they want to know which of the following best approximates the total number of barrels of oil. So our answer should be in terms of barrels of oil. And we want to know how much passed through for the day, so in 24 hours. So the key is, if the y-axis is in barrels per hour and the x-axis is in terms of hours, if we multiply them, or in some sense find the area under the curve, when we multiply barrels per hour times hours, the units cancel and it gives us the unit that we want for our answer, barrels. So if we look at these, be careful, the axes don't go up the same. This is 6 by 100. So each of these squares represents 600. Or I should say squares, rectangles, even though they look like squares. So all of these are 600, and if you look at the top, these are kind of like half of the rectangle. So then these pieces would be 300 each. So what this tells us is that we have 600 5 times, so the approximation is going to work out to 3,000 for the total number of barrels. But once again, the concept here, why are we doing area? Because it's barrels per hour times hours. The units cancel, giving us just barrels. For the next part here, we want the instantaneous rate of change. That's a fancy way of saying take the derivative. So we're going to take the derivative of f, and then when we're done taking the derivative, we're going to plug in 2. So we're going to use quotient rule, and it's kind of lame, but it works. The song low d high minus high d low over low low. So we write the low part, low, and then d high represents the derivative of the high. So the derivative of the top is 2x minus high. The high function is x squared minus 2 times the derivative of the low is 1. So times 1 over low low, or the denominator squared. Now for this part here, you could spend time simplifying, but it's multiple choice and your work is not as important, so just plug in. And if you plug in, you'll have 2 minus 1 is 1. 2 times 2 is 4. Minus, and if you do 2 squared minus 2, that's 4 minus 2, which is 2. Over, and that's 1 to the second power. And this just works out to 4 minus 2, which is equal to 2. Okay, for this question here, we have if f is a linear function and 0 is less than a less than b, then, and we have a definite integral with f double prime. Word of advice, when you get an if-then statement, you could always assume the if is true. So pick out your favorite linear function, maybe it's 2x minus 3, And then just run this through the problem. If f of x is 2x minus 3, then f prime is equal to 2, and f double prime of x is equal to 0. So if we want to find the integral from a to b of f double prime, which is 0, well, the integral of 0 is just 0, and that gives us choice A. So plug in something, save yourself a lot of time. For the next question here, we want to find the limit of a piecewise function, so we should check the left side, and we should check the right side. So we're going to plug in 2 to the left side, and we're going to plug in 2 to the right side. And to identify the left side that's less than or equal to 2, would refer to the top piece, since x is less than or equal to 2. And if you plug in 2 to that part of the function, you're going to get natural log 2. If you plug in 2 to the right side of the function, then that's going to give you 2 squared natural log 2. And remember, to identify the right side, it's for values of x that are slightly greater than 2. And if 2 is less than x for the bottom piece, we're plugging in here. And this gives us 4 natural log 2, which would give us natural log of 2 to the 4th, which is natural log of 16. But the point is, the left limit and the right limit are different. And if the left limit doesn't equal the right limit, the limit does not exist. For this question here, we have a graph of a function, and they're telling us there's a vertical tangent at the point 2, 0, and horizontal tangents at the points 1, -1, and 3, 1. And we want to know between -2 and 4, for which values of x is f not differentiable. So the key is to find out where a function is not differentiable. You could show that it has no limit. So this is one way. You could show that it's not continuous. And another way is to show that there is a vertical slope. Okay, so these are 3 that just come into play here. So if you look, is there any place on the graph where there's either no limit or it's not continuous? And that's true when x is equal to 0. At this point, there's a break in the graph. So that means x equals 0 is the first place where this function is not differentiable. So choice C is out because 0 is not part of it. So then the next thing we want to look for, oh, I should have also mentioned, I'm sorry, a fourth one is a sharp turn in a graph. But this graph has no sharp turns, so that's not going to be one we're going to look for. Now they told us there's a vertical tangent at 2, 0, which is here. So this means that x equals 0 and x equals 2 are locations where f is not differentiable. So the function is not differentiable at 0 and 2 so far. So A is out. This choice is out. And now it's stuck between choice B and choice E. But if we look at 1 and 3, the slope, we have a horizontal tangent, which means the slope is 0. And a 0 slope is definitely allowed. So that means choice E is out. And it's going to be choice B here. Now remember, it's 0, f is not differentiable at 0 because it's discontinuous there. And at 2, there's a vertical tangent. And a vertical tangent means no slope. Now for this question here, we have a particle going along the x-axis. And we have the position function. And we want to know for what value of t is the velocity equal to 0. So to find velocity from position, we need to take the derivative. The derivative of position is equal to velocity. So that means if we want to know when velocity is equal to 0, we're going to take the derivative of our function, and we'll get 2t minus 6, and then we set it equal to 0, which gives us 2t minus 6 equals 0, which tells us if we add 6 and divide by 2, this happens at t is equal to 3. For this question here, we're going to use Fundamental Theorem of Calculus Part 2. They're telling us to take the derivative of an area function. And if we take the derivative of our area function, it's the easy case where our lower limit is a constant, our upper limit is a single variable. So to take the derivative here, just remember, it's kind of like saying the derivative and the integral are opposites. They cancel out, and this gives us the square root of x to the third plus 1. But we want to evaluate our derivative when x is equal to 2. So then we just plug in, and we'll have 2 to the third power plus 1, which gives us the square root of 9. And the answer to this one is going to be choice D. For this question here, we have f of x is sine of e to the negative x. And we need to use chain rule, but there's three functions. There's sine, there's e, and there's negative x. So the shortcut is to start from the outside and work your way in. You take the derivative of sine, and you're going to get cosine. You keep the inside the same. Now the second function is e. The derivative of e is e. So we're going to have times e to the negative x. And then we multiply by the derivative of the last function, which is negative x. And that works out to negative 1. So for this question here, we're going to have negative e to the negative x cosine of e to the negative x. And this works out to choice E for this one here. For this question, we have a graph of a twice differentiable function f, and we want to order f of 1, f prime of 1, and f double prime of 1. So the key is, if we're given the graph of f of 1 is simply the height of the function. So to find the height of the function is the point 1, 0. So f of 1 is simple to find. F prime of 1 means the slope. So for this one here, we should be thinking slope. And if we look at the slope here, since this function is increasing, the slope is equal to something positive. So we could just say for this part here that the derivative at 1 is positive. So it's greater than 0. And if we look at the second derivative, we'll be talking about concavity. So if we look here, because this graph is an upside down U shape, this is concave down. And if it was going this way, it would be concave up. And if it's concave down, this means the derivative is negative. I'm sorry, the second derivative is negative. So since our graph is along this upside down U portion, that means our second derivative is negative. So if we put these in order, the negative is the smallest, which is the second derivative. 0 is in the middle, so that's just the function is 0. And the positive value is the greatest, so that one's going to go all the way to the right. So we should have f double prime, f, and then f prime, which is going to be choice D here. For this question, we want an equation of a tangent line, and to find that, we need a slope and we need a point. The point they gave us is the point 0, 1, and this also happens to be the y-intercept. But to find the slope, we're going to use the derivative. So we need y prime equals, and the derivative of x is 1. The derivative of cosine is minus sine x. So if we plug in y prime at the point 0, 1 is equal to 1 minus sine of 0, and this is equal to 1. So since we have the y-intercept, we could just use mx plus b. The slope we just found is equal to 1. So we're going to have 1x plus, and the y-intercept here is equal to 1. So the line is going to be y equals x plus 1, choice B. Now for question 19, they're giving us the second derivative in factored form, and they want us to find the points of inflection. If you're not careful, people are going to do this. They're going to set the second derivative equal to 0, and they're going to say that this is true when x equals 0, x equals negative 1, and x equals 2. They're just simply going to take the opposite of each factor. But the problem with this is a trap big time. You have to look for a change in sign in f double prime. So you make a number line here, and you cut it at negative 1, 0, and 2, and you're going to plug in numbers in each of these four intervals to determine the sign. But the trick is that if you do this, the shortcut is to plug it into the factored form. I would not recommend expanding this. That'll take you way too much time, and it'll waste your time as well. And also, look at this factor here, x minus 2 squared. It's important to know that this factor is always positive because it's being squared. So when you do plug in, you really just have to plug into the first two factors to check. So if we look here, let's say I plug in negative 2 for the first interval. If I plug in something like negative 2 into the second derivative, I'm going to have negative 2 times negative 1, which works out to something positive. If I plug in, and this is all going on mentally, let's say negative 1/2, I'll have negative 1/2 times positive 1/2. And the negative times the positive is going to work out negative. Between this interval, I would plug in 1, and I'll have 1 times 1 plus 1, which is 1 times 2. That's also positive. And for the last one, and this is the sneaky one, if I plug in 3, I'm going to have 3 times 4 is positive. So it's important to know here, the reason why we had to check is because there is no sign change at 2. So this tells us that at 2, there is no point of inflection. And the only ones that are going to give us points of inflection are at x equals -1 and 0. So 2 has to be omitted because there is no sign change. So this is going to be choice C. So remember, do not assume that there will be sign changes because they love throwing in traps. Okay, for this question here, we're trying to solve for which value of k would make the definite integral of this expression here equal to 0. Well, right away, this one is always something to look out for. If the lower and upper limits match, so like if it was -3 to -3, then that would make your derivative, your definite integral, automatically 0. So your answer must have -3 in it. So that means B is out, C is out, and now we're stuck between choices D and E. But if you think about what the question is asking, it's asking for area under the curve of x squared. So if we look, if we made the upper limit, let's say +3, if we went from -3 to 3 of x squared, this would give us something positive. See how we have actual area. So 3 cannot be an answer. And if 3 can't be an answer, then it's definitely not going to be choice E, and it's definitely going to be choice A here. The reason why 0 is not allowed either is because that would say the area from -3 to 0, which is also positive. So from -3 to 0 is also not allowed automatically because the area will come out positive. So it's definitely choice A. Okay, for this question here, we have that k is a non-zero constant, and we want to know what y could be. And we have some differential equation. So what we could do is we could separate variables. So if we have dy dt equals k times y, we could divide both sides by y, which is the same as multiplying by 1 over y. And we could multiply both sides by dt. So dt over dt cancels on the left, y over y cancels here, and we'll have dy over y is equal to the constant k times dt. So to solve this more, we're going to take the antiderivative of both sides, and on the left, we'll have natural log absolute value y, and on the right side, the antiderivative of a number is a number times the variable, and the variable on the right side is t, so we'll have k times t plus c. So to get rid of this natural log, we're going to make both sides an exponent of e, and now we'll have absolute value of y equals e to the kt plus c. Now, I know we have to treat y as plus or minus. However, none of the answer choices have a negative, so we'll take the positive part of the absolute value. And on the right side, we could rewrite this as e to the kt times e to the c. So when you get to this stage of solving this problem, we have to think a little bit more, and notice e to the c is constant because e is a number and c is implied to be a constant after we take the antiderivative. So a number to a number is constant, and if we let e to the c equal to, which we're allowed to do because they're saying y could be. It's not like we have an initial condition and we have something exact. If we replace e to the c with 2, we're going to have 2e to the kt, which matches choice B here. So for question 22, we have a function f of x, and they're asking us on which interval is f increasing. So the moment you hear where is the function increasing, you should think first derivative test, and basically you're going to make a sign chart for the first derivative. So we need to use power rule on the original function, and we'll get 4x to the third plus 2x. We're going to find the critical values, or basically the zeros. So to find the zeros, we're going to set this derivative equal to 0, but we're going to factor out the GCF. So we'll have 2x times, and we're left with 2x squared plus 1. So what we need to do is we need to find the roots. And to find the roots, notice the first factor is just going to give us x equals 0. But the second factor is always positive. 2x squared plus 1 has no roots because it is always positive. So the only critical value that we have is at 0. So now we need to assign a sign to each interval, positive or negative. So we plug in -1 to the derivative. And I would plug it into the factored form. The second factor you don't even have to bother with because we said it's always positive. So if you plug in -1, you'll have 2 times -1 is negative, and a negative times something that's always positive is going to work out negative. If you plug in something like +1, you're going to have positive 2 times +1 is positive, times a positive factor is always positive. So if we want to know where is f increasing, f is increasing has the same meaning as f prime is positive. And f prime is positive on the interval from 0 to infinity, this part here. So this is going to give us choice C. Okay, for the next question here, the trick to this problem, we have the graph of f, and we want to know which of the following answer choices could be a graph of the derivative. We have to look at the behavior of f. Where is it increasing and decreasing? And this is going to help us eliminate some choices. So if we look here, the function is increasing until it gets to the top of this hill, and then it starts to decrease. So if it's increasing from, let's say, a to c, we'll call it, that means the derivative is positive on the interval from a to c. But since the graph starts decreasing from c to b, that means the derivative should be negative on the interval from c to b. So when we look at the answer choices, we need something that's positive from a to c and negative from c to b. So if we look here and we mark these off at the point c that we labeled before, this is going to help us answer this question. So we eliminate choice B because you see how this graph is always positive, and we need something that starts off positive and then goes negative. C is no good because it's negative for the first portion of the graph, but we need it to be positive from A to C. So this choice is out. This graph is no good because it starts off positive, then it goes negative, then it goes positive. But according to this graph, the derivative should be positive all the way here and then negative for the rest. So D is out because it's positive, negative, positive. And now we've narrowed it down to choice A and E because E on this graph, it starts positive and goes negative. So then if you narrow it down to 2 choices and you don't know what to do from there, like at least you have a 50-50 shot of guessing. But to find out which one it definitely has to be, we should talk about concavity. So if we look here, the graph is concave up anytime it's in the shape of a U, and it's concave down when it's in the shape of an upside down U, which means the second derivative is positive, and this, for the concave down, the second derivative would be negative. But another way of saying this is if we have concave up, that means our derivative should be increasing, and if we have concave down, our derivative should be decreasing. So if we look here, you see how it's concave up because it's in the shape of a U. That means our derivative should increase, and then our derivative should decrease. And then for the next portion where it's concave down, the derivative should continue to decrease and switch back to increasing. But if that gets a little bit confusing, the reason why E is out is because this derivative is always decreasing. And if the derivative is always decreasing, that means f double prime is always negative. But this graph is not just concave down, it's concave up on this component here, and it's also concave up on this component. So that's why we eliminate choice E, and we're going to go with choice A here. Okay, for this question, we want to find maximum acceleration on the interval from 0 to 3 when we know the velocity function. So to maximize a function, we need to take the derivative of the function to be maximized and use the closed interval method. So the first thing we should do is find the acceleration, which we do power rule on velocity, and we're going to get 3t squared minus 6t plus 12. But the mistake would be to set this function equal to 0 and start solving. We're trying to find maximum acceleration. We're not finding maximum velocity. So the fact that this is the one to be maximized means we need to find the derivative of a, which is 6t minus 6, and we're going to find the critical value. So this is equal to 0 when 6t minus 6 equals 0 or when t is equal to 1. But the way we find a maximum value or an absolute minimum value is we use the closed interval method. So we're going to plug 1 into the acceleration, but we also are going to plug in the endpoints 0 and 3. And whichever one is the biggest number is the absolute max. So if we plug in 0 into acceleration, we're going to get 12. It's just the constant at the end. If you plug in 1, you're going to get 3 minus 6 plus 12, which is equal to 9. And if we plug in 3, we're going to get 3 times 3 squared, which is 27, minus 6 times 3 is 18, and then plus 12. And this is going to give you 21. So the absolute maximum number in this list is 21. So choice D is our answer to this question. And remember, this is the finding absolute extrema on a closed interval. Okay, for this one, we want to find the area between the graphs of y equals x squared and y equals negative x from x equals 0 to x equals 2. So what I recommend doing here is drawing this. X squared looks like this, and negative x looks something like this. So if we're finding the area between them from 0 to 2, that means we're finding the area of this section here. All right, don't fall for the trap and find the area of this section. We're finding this area because they told us from 0 to 2. So if you look at one of these cross sections here, okay, the thickness of one of these rectangles is dx. And to find the height of the rectangle, we're using the concept of top minus bottom. The top function is x squared, and the bottom function in this section is negative x. If you fall for the trap of being stuck here, you're going to put negative x up top, x squared down bottom. But since we're in quadrants 1 and 4, the top function is x squared, and we're going to have minus the bottom function, negative x. So if we treat this as a differential, this one slice of area is x squared plus x, and it's length times width, so we're going to multiply by dx. But if we want the whole area from 0 to 2, then we're going to take the integral from 0 to 2 of x squared plus x dx. And now this is just FTC part 1, the fundamental theorem of calculus. We'll have 1/3 x to the third plus 1/2 x squared. And we're going to evaluate this from 2 to 0. So the next progression here is that we're going to have 1/3 times 8 plus half of 2 to the second power is 4. And then when we plug in 0, it cancels out everything. So the second parenthesis is very easy to deal with. And we'll have 8 over 3 plus 4 divided by 2 is 2. So you're going to have 8 over 3 plus 6 over 3, which works out to 14 over 3. So this one is going to be choice D. Okay, for this question here, we have f is continuous on the closed interval from 0 to 2, and they gave us values in the table. And they're asking the equation f of x equals 1/2 must have at least 2 solutions if k equals. So my best advice for questions like this is, if you can, draw it out. Okay, so this thing is going from 0 to 2 on the y-axis and 0 to 2 on the x-axis. So if we look here, we're going to have 0, 1, and 2. So 0, 1 is definitely on this graph, and 2, 2 is on this graph. But they're asking us the equation f of x equals 1/2. And think about that. F of x equals 1/2 is just a horizontal line through 1/2. So they're saying for what value of k, so we're basically looking for the y value, will this function f hit this horizontal line twice? And this is the intermediate value theorem here. So the key is we need to pick an answer for k that is less than a half. If we choose something that is 1/2 or greater, we can't guarantee that when we connect this point that it's going to pass through this line twice. So the only one that is less than a half is 0. And think about, why does this answer make sense? Well, because if it's continuous, I have to pass through every height in between. So on my way from 1 to 0, like when we write our 0 here, on my way from 1 to 0, I have to pass through 1/2. So that means I cross at least once. But then to go from 0 to 2, I'm going to have to pass through 1/2 a second time. So these locations here represent where we must have at least 2 solutions. Remember, if we picked anything else, like 1 or 2 or 3 or even a half, we could not guarantee 2 solutions. This would only guarantee 1 solution, and the other ones don't guarantee any solutions. So the concept behind it is intermediate value theorem. Okay, if we want to find average function value, we need to know the formula 1 over, and let's say this is a and b. We're doing 1 over b minus a. So that's 1 over 2 minus 0 times the integral from 0 to 2. And we just write our function in there. X squared times the square root of x to the third plus 1. To evaluate this, we're going to need to do a U substitution. So you let u equal x to the third plus 1. Then du is 3x squared dx. And if we solve for the leftovers, we're going to solve for x squared dx. That tells us that 1/3 du, after multiplying both sides by 1/3, equals x squared dx. But the last thing we should do is find new limits. So far we have that this is an important item, and this one here is going to be important to the question. So the new limits we could find by plugging in the old limits into our definition of u. So if I plug in the old limit 2 to the third power plus 1 is equal to 9. And if I plug in the old limit 0 to the third power plus 1 is equal to 1. So these 3 components help you rebuild the integral. So we're going to have 1/2 times, and the new limits are 1 and 9. And we'll take care of this part first. Radical x to the third plus 1 we could call radical u. And x squared dx we solved for before is 1/3 times du. And if we work this out, this is going to be 1/6 the integral from 1 to 9. And instead of radical u, we'll call it u to the 1/2 du. So all we did was multiply 1/2 times 1/3. So then to simplify this integral, we are going to have 1 over 6 times, and the antiderivative of u to the 1/2 is u to the 3 over 2, times the reciprocal. We just flip the new exponent, and this is going from 9 to 1. And remember, 2 over 6 we could reduce to 1/3. So now we're left with 1/9, and now we plug in the limits. We're going to have 9 to the 3 over 2 minus 1 to the 3 over 2. So then to simplify this expression here, we have 1/9, and 9 to the 3 over 2, the square root of 9 is 3, 3 to the third is 27, 1 to any power is 1, and this is going to give us 26 over 9, which is choice A for this problem. Okay, now the last question here, we have f of x is tangent at 2x, and we need to find f prime at pi over 6. So the first thing we should do is take the derivative of tangent 2x, and the derivative of tangent is secant squared. We leave the inside the same, but we have to use chain rule, multiply by the derivative of 2x, which is 2. But then when you get to this stage here, you'll be surprised how many students forget the trigonometry for this. So please don't let this be the part that gets you. It'll be very sad. It'll be a very sad day at the office if you get this far and then this is where you mess up. So when you plug in pi over 6, 2 times pi over 6, just know is pi over 3. All right, and in your head, you want to think of this as 60 degrees. Okay, that's going to come into play in a moment. So we have secant squared at pi over 3 times 2. So remember, secant is associated with cosine. And if you think cosine at pi over 3 or cosine of 60 degrees is equal to a half. So that means that secant at pi over 3 is the reciprocal, too. So then secant squared at pi over 3, if we square both sides, is equal to 4. So to simplify this, this is just 4 times 2, which is equal to 8. So this works out to choice E.